This is Gemma RescueGrid, a multi-agent disaster response prototype I built for the Gemma 4 Good Hackathon. Gemma 4 acts as the planning agent for 3 drones, thermal, camera, and medical, coordinating on a 5x5 disaster grid. Let me show you what it does. There are 6 disaster scenarios: urban flood, earthquake aftermath, industrial fire, building collapse, coastal surge, wildfire. I'll pick urban flood rescue. 7 weather conditions, each affecting how the drones operate. I'll pick high wind east sector, wind that should affect flight stability in part of the grid. Drone 2's battery is set to 22%, low but still operational. Below 20 triggers a low battery status. 0 means the drone is offline. A few seconds before I started this recording, I hit submit. Gemma 4 read the scene and produced this mission plan in about 20 seconds, all inference running locally on a single T4 GPU. No internet, no cloud API calls. Here's the plan. The thermal drone, the orange triangle, is heading to the flood at 1-3. Heat sensors work through water. The medical drone is moving toward the high-priority civilian in the upper right, and the camera drone is holding in reserve given its lower battery. Below the map, Gemma's reasoning is summarized. Look at the first risk. High wind conditions in the east sector may affect flight stability. That's not boilerplate. Gemma read the weather input and produced an operationally relevant safety concern. That was a single Gemma plan. But the real story is what happens mid-mission when things change. In the full simulation, 2 things go wrong at once. A drone fails, its battery hits 0, and a new hazard appears on the map, a flash flood that wasn't there when the mission started. Watch what Gemma does. Here's the result. 3 hazards on the map now instead of 2, the original flood and debris plus the new flash flood at 2-4. The background is tinted darker because the weather escalated to severe storm. The failed drone is marked with an X at its last known position, so search and rescue can find it later. And the 2 surviving drones? Gemma reassigned their targets, and the drones moved further along their new paths. The thermal drone advanced toward the flood. The medical drone advanced toward the high-priority civilian. The system absorbed 2 surprises and kept operating. The point I want to land: this runs locally. After model load, 0 network requests. That matches the offline resilience requirement of real disaster response, where cell towers are the first thing to go down. Built on Gemma 4 E2B, small enough to deploy on a field laptop, smart enough to reason about a changing disaster zone. Thanks for watching.